Aquarium at the Dauphin Island Sea Lab and to our Boardwalk Talks program. My name is Mendel Graber. I am one of the educators here at the Sea Lab, and this is Rachel McDonald. Rachel is an educator with the Discovery Hall programs here on campus, and she is the ROV instructor extraordinaire. So Rachel is going to talk with us a little bit about ROVs, what they are, how they're used in science and in other industries, and how they are putting ROVs into classrooms and letting students build them. And then after that, I think you'll have an opportunity to try your hand at operating one. She brought one and a pool to drive it in. So with that, I'm going to let Rachel tell you a little bit more about ROVs.
Well, thank you, Mendel. That was a great introduction. As she said, I kind of have the education team in getting to do a lot more than, not that they only teach students, but my extra stuff that I do is working with these underwater robots and all the various ways we use them that I will tell you about as kind of the second half of the talk. So you'll get to hear about all my other mini jobs with working with these cool underwater tools. So what I have in front of you, and I'll pull this off the top, is an ROV, or remotely operated vehicle. And these are some small ones. I'll show you some pictures of all the various sizes here in a minute. But that stands for remotely operated vehicle. So from the name, you can already get a little hint about how these vehicles operate, right? The key things to notice is, you can see, there's no room for anybody to go on them, right? We can use these or shallow water ROVs, but they do use them in the deep sea as well. So one of the first things I wanted to tell you, besides that they are not occupied, is some of the different parts that you see in front of you. So I have two kind of set up all together, but I'm going to hold up to you kind of the essentials of what makes an ROV an ROV, and I have it set out on the table right here. So here we have the really fancy student version of a remote, right? So they're and they are tethered. So if you notice all this cable I'm holding, I'll talk to you about it in just a minute. But if you were out on a boat, right, you would have this nice remote if you're holding it this way. How would you guys imagine a larger ROV might be driven? Anybody have any ideas? You'd be in a nice fancy, did you have an idea? Sorry, you moved.
Oh.
No.
I've seen ones that people can go in. Well, no, but that's not really remote necessarily.
Mm-hmm. So that's a whole other type of underwater class of vehicles, but I can mention them because yes, they're really cool too. So you can actually drive them from inside the cabin, and what you do is you'll be watching them from a screen, right? Now the one we're driving today is not going to have a camera on it. It's not very exciting to get to drive it in a little tub and look at the sides of the black tub. But most of these would be driven, right, with the pilot in a nice comfy room, and then the ROV could be however deep that ROV was made to go. So it could be thousands of feet below the surface, and they're driving it from a screen. Anybody in here good at simulators, video games, that sort of thing? Anybody want to admit to being good at those? Yeah, okay. I've had a lot of practice with this type of it, but those pilots are trained, right, via simulators, right? That ROV can be thousands of meters even below them, and so they drive everything and operate it from a screen. So that really can be a life skill. I always tell that to the students because some of them are great at those, and they're always told that's not going to get you anywhere. But in today's coding and electronic world, it really can take you places, and even offshore if you wanted it to. Not that I'm telling you guys that raise your hand, you have to go offshore. Lots of other great jobs too, but cool one for simulator and video games. So what we use with the students and what you see in front of you, and if you stick around we'll get a chance to use today, are these smaller remotes. And you can kind of see what's nice about this one is you can see inside the box. So you can see it wired, right? Each of those switches wired directly in the back of the box. And I'll let you guys come up and look at this stuff too later if you're interested. Right, these connections from these switches run all the way down this tether. And this has to connect all the way to the ROV for it to operate. Unfortunately, now if you want to make some good money, you can come up with a way for them to communicate directly from the surface to the seafloor at that distance. And what advantage this gives it is they can do it live. So the pilot within, milliseconds is making that ROV operate by having this direct connection, right? So they call this the tether or the umbilical. This one's got about maybe 8 or 9 feet of tether. This is when I use in a pool, right? I'm not needing to go so deep. The big ones that I'll talk about here in a minute. Oop, I knew I was going to catch that cord, Mendel. This is part of that umbilical, right? Or tether cable that connects from the surface, right, all the way down to the deep ocean. I'm going to hold up a picture here of one of the ones I like to talk about. This is the Jason ROV. And he can cover about 90% of the ocean depth. I think he can go to about 6,500 meters. So imagine someone's job on that vessel, a part of that ROV crew, right? The pilot's not, this isn't his job. He's in there piloting that ROV. It's somebody's job to manage this cable, this tether. And I don't know about you, but I really dislike wrapping Christmas lights and all of those tether cables and seeing the mess of them. So this is quite a job. This is the most expensive part of your ROV for the most part because of how much of it that you have to have. And they can make these fiber optic cables as well. I'm going to pass this around.
Can I pass this, or did you want to refer back to it?
No, you can pass that one around. So that one is a large, what we would call working class ROV. I'll talk a little bit about some of the different sizes. Imagine a large SUV, right? If you flip it over, if you want any of the quick stats on it, I did write its size on the back of it. Just as a quick reference for me, I'm not always good at remembering numbers, but it tells you the size of the Jason and how deep it can go down. I'm going to pass this around as well. If you really want to know what all the parts of it are for, the company that donated this to us was nice enough to send me a little bit of information as well, so you could read which one's running like camera power, which one's doing the ROV power, and what the open tubes are for also. Lots of different things you can run that down. So everything on the ROV itself, right, everything you see here on this body gets powered from the surface with this tether, which is really kind of cool, right? If you've ever had to think about waterproofing a battery, not the easiest thing to do. You don't want it to corrode. You got to think about pressure as well. So it reduces the risk of having that battery down below have any issues by powering it from the ship, which is kind of nice. But it means you have to make sure that tether stays in good shape. Then we get to the end. And the basics that you absolutely have to have, right, are your motors, which are going to help you maneuver it, right? So these are some simple bilge pump motors with some adapters and propellers on them. So this basic ROV, just like this one here in the middle, I'll hold it up a little bit more so you guys can see it and not catch this cord, is, and I've got the cord weighted down here. You want to hold that part? Yeah. Thank you, Mendel. Is you can see the so I have 2 motors facing the back. It allows it to go forward and backwards and turn, and then it allows it to move up and down. All right, we can set it back down. I just wanted to briefly let you guys see the motors. So that's kind of the basics of what has to be on an ROV. Somebody else think of something else that you might want to have on your ROV if you're down 6,500 meters. Obviously, you want to move around with power in those motors. Lights. It's dark down there, right? We only get we need lights on it. Anything else? What else might you want to know? Buoyancy. So we need something to allow it to not just sink, right? If your ROV is rated for 6,500 meters, do you want it to go 6,700 meters? No. Anybody know what we call what happens to that? You explode in the air. What do you do underwater? Implode, right? They would get crushed. So to prevent that from happening, right, they definitely have to have some really good buoyancy. That big ROV that you're passing around the sheet on, this is the buoyancy material on the top of it. I'll pass this around too. It's really hard. This is called syntactic foam. But unlike pool noodles that would get crushed, right, the air would get squeezed out of them, this does not crush under pressure. And it helps it have what we call neutral buoyancy, right? So you don't want that ROV to just sink to the bottom. You sit at the top. The whole point is to go down and explore as maybe one of the uses underwater, right? So we use this cool material called syntactic foam. I have an info sheet on it as well if you want to read about the process of how they make syntactic foam, as well as feeling what this, it's going to feel kind of like a block of wood.
Can withstand pressure?
They will make it to different ratings depending on what that ROV or the human-occupied vehicles like the Alvin are rated to go to. This will often be an outer layer on it. For ROVs, it's typically always on top. So I think on that picture you guys passed around, it's the yellow and blue on the top of it. About the different type of spheres they use. So this is more of just kind of the resin that they fill it with. This is going to show you some macrospheres and microspheres. They actually use glass beads within it to help it adjust and have that neutral buoyancy. And it talks about one does 10,000 meters, another is only for 2,000 meters. So they do customize it to that vehicle. The Jason is one of the deepest ROVs that I know, about 6,500 meters, because they can get to most of the ocean bottom. I don't know, I forgot to look it up, if there are any currently, and Robert, if you know of one, that can go down into the deepest place in the ocean. I don't know of any that are currently, definitely not within the U.S., for the Marianas Trench, which is the deepest place in the ocean, and that's at 11,000 meters. And this talked about 10,000 meters depth for some of their rated syntactic foam. So that's a great question. So we've got the foam, right? We need that buoyancy. We don't want it to go too deep. We need lights on it. You can see a couple cameras. Anything else you guys can think of you might want? And there's not one on here to show you.
We have ways to sample.
Ways to sample, right? So a lot of times they're going to have different types of arms or claws. A lot of them operate hydraulically. So if you look at that chunk, that tether, some of those tubes are on there to allow hydraulic fluid to run down to the ROV and allow those claws on the front to operate. I don't think this picture shows it. These are some other ROVs that I kind of have pictures of here. I think on the Jason, who has the Jason photo? Does it show a claw? You can see the two claws that it has on the front. So you're sending something down and it's great to be eyes underwater, but it's even better, right, when you can bring something back. Now the technology in the claws is rapidly changing. If you just do a search for like hydraulic claws underwater, some of the new stuff they can do with 3D printing, they're making some soft, rubbery ends for the hydraulic claw to pick up soft corals and sponges, things you don't want with just metal parts to pick up. So they're working on ways to collect some of the soft stuff as well with those hydraulic claws that are on them, which is pretty cool. Anybody else have any questions as I'm talking? Well, I've got plenty more to share, but I wanted to pause for a second if anybody had any. Anything you wanted to interject at this point, Mendel?
So you were talking about different components, the frame itself.
Yeah, so what about, I asked the students this question, that they're our classes, that's the main part of the build for them, is I give them a to design the frame. On mine, we use some really simple material that we use with the students, PVC, right? It's pretty cheap. We can buy all to put it together. We use metal a lot of times for it. And one of the things you'll notice with that deep one, that I'll hold it up again, I'll have Mendel hold it up, is that it's open, right? It's flow through. What advantage does that have? You might be able to think of a disadvantage, right? On that ROV needs to be waterproofed. Can you think of what the advantage might be? Right? That pressure, less drag, right? So sometimes it can help it with maneuverability, but pressure, right? Some of the smaller ROVs, and I'm going to go ahead and hold up this poster for a second, and I'll lay it out afterwards, so don't worry if you can't see or read everything. But if you notice towards the top here, some of the smaller ROVs that are made for shallower inshore work are closed body, right? And they can be that way because there's not as much pressure, right, that's being exerted on them, and it can help them with their maneuverability in the shallow water. But they're not good for the deep ocean. So you can see they really do come in all different shapes, sizes, and colors when you're looking at the frame, right? And that's really up to how that ROV is going to be used. So we're going to talk about that in a minute. The other thing,
also just going back to the arms for just a second, the claws. So you mentioned sampling as one of the functions of those, but they might also, there are people who will use ROVs to do work, so at depth. So not just using the arms to collect things and bring them to the surface, but to actually work underwater.
Yeah. I'll chat a little bit more about it, hopefully I don't forget. I'll kind of set this here. It's going to roll up. It hasn't been up long enough to stay up on its own. But the other thing we're going to put on there is, obviously we want the claws to collect stuff. They're going to put various sensors on it, right? They want to know what depth they're at constantly. Temperature, I don't know about any of you, but before I get in any water, I want to know what the temperature is. Depending on the research or the work that's being done, there may be other things they want to measure as well. And we can talk about the various sensors too if you're interested in knowing the different things we put on them. A lot of times how we use them for the classes, if we add anything, it's a claw and a camera, right? We have done thermistor, so looking at simple temperature sensors is kind of the simplest one to start with to add something like that onto it. The other thing, I'm going to grab this photo again, down here at the bottom, most of that is changed out between every ROV mission, and it is what they collect, all of the different samples that they might collect and store it while it is underwater. So that can really change depending on the day or the time and whatever that mission is that they're out there. So the next thing I wanted to share with you is we kind of talked about what an ROV is, the parts of them, is how they're used. So who can think about something an ROV might go underwater to do? And I'm sure you guys can come up with some of them.
Explore a wreck.
Explore a wreck, right? So archaeology, marine archaeology is definitely one that happens. I have a picture of an ROV exploring a rather famous shipwreck. Anybody recognize this one? I know it's a small picture of the shipwreck, but if you look up there, the Titanic, right? So the is credited with finding, right, the Titanic, and this one is the Jason Jr. that was made. Think about that big ROV here. It's not going to fit inside the Titanic, but you send the smaller one down, right, and you can actually go in and check out and explore internally. That one's not good at collecting things, but obviously we have collected items from various shipwrecks. Sometimes we don't. We intentionally leave them because they are grave sites. And so there is a whole group of individuals that use ROVs in studying marine archaeology. They do occasionally find shipwrecks still in the Gulf of Mexico. They recently found the one, what was the shipwreck they found up in the north? I'm blanking on it, and we did a competition on it 2 years ago. It wasn't the Endurance, or was it the Endurance? Anyway, it'll come to me in a...
German submarine they found.
Found a German submarine, but there was the famous one that had been lost for forever in the ice. We're all thinking of it, but it'll come to me in a little bit, sorry.
Fitzgerald?
No. It was an Arctic expedition, and they finally found the shipwreck. And so they can send ROVs down, obviously, to study that. All right, how else can we use ROVs? So we can look at marine ships, right? Sunken ships, pretty cool. You're at a nice research, right, lab, Dauphin Island Sea Lab. What about? Definitely, right? Inshore work as well as offshore work. So here at the Sea Lab, we have a fisheries lab on campus. They have some small ROVs, and when I say small, what they call Snapper Kitty is her name affectionately, is about this big in size. So about the width of the table and about 3/4 of the length. And it has some extra cool things on it. It does have an arm, and it also has some sonar on it that they're working on to see how they can use sonar to look at some of the artificial reefs offshore as well and study those fish populations. So take lots of video, go back through, they can get total abundance. You add lasers onto an ROV, not to fry the fish, but if you have two side by side, what is that going to tell you?
Size.
The size. So they can get a size estimate without ever having to collect that fish. And they've collected enough fish now that there's a frequency to relate size, right, to weight, and so they can get an idea of that. Doesn't work so well for aging. They do have to collect some fish for aging. You can maybe get an estimate. It's going to be at least this old, but we don't really know how old it is. But they can get some really cool data without ever having to bring those fish to the surface now, which is really cool. And not everything's going to be caught, as anybody that fishes knows, on hook and line, right? Especially lionfish are invasive species around here. Those don't do well that way, but they can get an abundance of that invasive species by looking at that.
Well, and yeah, you might know a number better than I do, but if you imagine they're recording this video of these fish, and from this they are going to do these estimates of abundance and size. And so how long is the video processing? So say you've got like a 15-minute video. How long does it take to process?
It can take them,
give them like a ballpark.
a minimum to a couple of hours. Sometimes it could take up to a day, depending on how many fish are on there and how many different length measurements they can get. So depending on the project, they might need to count all of the red snapper definitely on it. If they're looking at lionfish, they might go back and count the number of lionfish. Sometimes they have to try to verify what a fish is, right? As you get down with depth, you lose color, so we're adding light to try to help us, but things look very different underwater. So a lot of times it takes them at least a couple hours to process each little 15-minute or so video that they take. And they can take a 6-hour day offshore. They can have, at least 4 hours of video to try to process afterwards. So there's definitely a backlog of videos that they have. So another way, behind a computer, if you like that, counting fish, right, and measuring their abundance. All right, so research, underwater archaeology. How else might we use ROVs? There's some industry ways we could use them.
Construction?
We can do some construction. They can do, with some of the higher tech ROVs, some underwater welding. If any of you were around here in 2010, or think back to the event that happened then, the Deepwater Horizon oil spill, if you were able to watch any of that footage, that was video footage taken by an ROV, and then the claws that were working on repairing and stopping that leak, that was also ROVs down there doing underwater work, right? And the oil and gas industry is one of the largest ROV industries out there. They are the largest producers of commercial, those large ROVs that exist. And the company's based out of Louisiana, so not too far from us. And they hire people all the time to go offshore and do that type of work. So they can do some exploration work with it, trying to figure out the best places and actually going down if they need to inspect the area that maybe they want to put a new platform at. Then once the platform is there, they can do platform inspections, right? Make sure that what happened with Deepwater Horizon doesn't happen again, right? And they can do that without putting a body in the water. Now, platforms are kind of a dangerous area. You've got this nice cable, but risking tangling an ROV versus having a person underwater, there are the pros and cons to both of those. Now, if they do need to put a person in the water, they will often also have ROVs there. Have eyes in the water, you can see if an emergency is happening or what that diver might need, right? They can communicate to the surface instantly, which is pretty cool. There was a cargo ship, actually maybe it was a cruise ship, over, I can't remember if it wasn't Red Sea area, but over off the coast of Europe, that wrecked itself on a reef, and the captain abandoned it. They had divers in the water to try to salvage it and take it apart, and I saw videos of the ROVs. You're deconstructing welded material right all together, and so it's a great way to have eyes in the water if it's not doing the work itself. So yeah, industry and ports, we can use them to inspect ships, right, without having to bring them into dry dock. We could do a basic inspection, right, to know, does that ship need to go into dry dock to have work done. So they've definitely taken ROVs in all shapes and sizes to do them. I do want to mention, yeah.
Do they ever look for contaminants isn't the right word, but we deal with zebra mussels, things like that you maybe don't want going from one area to
Definitely, they can do that. And a lot of ships have to release their ballast water offshore before they come inshore, so they're not bringing any of those things into a harbor where those animals might survive, things like zebra mussels that would need more fresh water, but they definitely can look for things that are hitching a ride on ships. So most definitely on those materials, they can use them to inspect for those as well. It's a great example. Any other comments with that?
To just kind of make a connection between the ones that are used underwater and some of the drones that you guys might be even more familiar with. They've gotten to be so more common in our everyday lives. So if you can think of the kinds of applications that we have for drones, there are some analogous uses for ROVs in the water.
Definitely. We do use that term It's more coined by the military for underwater, but underwater drones versus air drones, right? You're just flying in a different fluid. So a lot of those principles, if any of you fly drones or the small aircraft and things like that, right, you're using those same engineering fluid principles, right, that you would be talking about. So military is also a branch that uses this quite a bit. They have some that drive on the bottom, more tank-like. I know it showed some in that poster, so when we lay it out, you can look at that. Underwater mining is growing. They can use track ROVs, which are the ones that actually drive across the bottom to do that. The last group I briefly want to mention, we've chatted a lot, and I want to talk to you school groups specifically, is exploration. There are 3 large ROVs, the Jason being an older one of them. He's still out there, but he's kind of semi-retired. He's not out there all the time anymore. But we have this one here, which is called the D2, or the Deep Discoverer. This one is owned by NOAA, so if you've heard that term, your National Oceanographic and Atmospheric Association, hurricane season down here, people definitely recognize the name NOAA, but they do a lot of great work for us. They own and operate an ROV that is out there at least 200 plus days of the year, just exploring, right? Just checking out what's out there. They're going to areas that we haven't explored. They're mapping, they're collecting things. Sometimes they find cool shipwrecks too. They live stream. You can watch when they're out there from your computer or your phone. Classrooms can also, if any of you are teachers or know a teacher, they can sign up to talk to, they'll take an educator on board, almost, I think all 3 of these vessels now, and at least 2 of them, you can connect with that educator, and they'll talk to you, your class of students, and tell you exactly what that ship is doing that day. So it's kind of cool. You could also be an educator at sea on one of these vessels with them. Dr. Robert Ballard, who is the one that you might have heard his name from the Titanic exploration work that he has done. He has a vessel, the Nautilus, and an ROV that goes out in the Schmidt Oceanographic Institute as well. And one of those names like NOAA ROV Livestream, it'll pull it up. January is not a good time. They're not often out in January, but they'll pick up once it warms up a little bit in March and April. They'll head back offshore. This is normally their time. A lot of them ships in dock getting ready for the upcoming season. So let me tell you, how do we use these with students, right? Now you know a little bit about them and what they are. So these are some examples of what we use with students. And one of the things we do is we have a field trip class. So if any of you have been to the Sea Lab before, you may have come through, and there's school groups coming through. Some of them just come to the aquarium, but some come across campus, right, what we call South Campus, towards the beach classrooms, and they take various, mostly field classes, so some are inside classes with us. One of them is called all the stuff we just chatted about. The students are given a pre-wired ROV just like this, and they have to design the frame of it with parts to take out to the pool and try to drive and be the pilot and the crew for about an hour and a half out at our Sea Lab pool. So they get a chance to do that, a great hands-on engineering STEM activity that they are getting a chance to learn about. I also have travel kits, mainly to the state of Alabama, but if any of you are educators or know an educator within the state, maybe they want to do this, but they can't come down to the Sea Lab. You can now check out a whole series of 6 of these kits from me, and I can ship them around the state via our traveling programs that we do. So we try to work out where they're delivered by van as opposed to freight. It's easier for us to take them and drop them off. But we can let teachers get a chance to introduce students to these, right? Alabama has a coast. We want students to know about ROVs and some of the cool jobs, right, that you could maybe do with ROVs down here along the coast. We also, which is my favorite part, I think, of my job, is we host student annual ROV competitions. So where students actually, through your school, club, however you want to do it, as long as you've got at least 3 people on your team, you can sign up and you would make your ROV from scratch. So it would be the student's job to wire this control box, connect this tether into it, waterproof the connections to your motors, and design your own frame. What's fun about our 2 different competitions is they both have pool tasks, if you will, of different, most of them are made out of PVC pieces, or sometimes there's other things, based off of real world ways that ROVs are used. So one year we focused on shipwrecks, and I built a fake shipwreck out of PVC, and they had to go through and explore, you know, that shipwreck and try to collect artifacts. identify an invasive zebra mussel that had covered it. So we focused on a shipwreck in the Great Lake, and so they were doing abundance counts. How many zebra mussels have covered this shipwreck? So they're science related. There's also math involved. We sneak those things in there from the education standpoint, but it's lots of fun, right? I don't know if you have any grandkids or students or yourselves, right, that would think that was fun. Both of these competitions are international. So they happen all around the world. We host 2 different regionals, what we call Sea Perch and what we call Mate. So if you're anywhere across the U.S., right, students can take part in these competitions. They also do a little bit extra work with it. Some of them you have to write a technical report along with it. So what did you do and why did you do it? How did you put this ROV together? For one of the competitions, I also have them either make a poster, so kind of like a poster that you would make for a science fair on the ROV itself, or give an engineering presentation in front of real judges that I bring in from the community. So I'll bring in coastal engineers and people, and those students get a chance to talk about all the cool stuff that they do. And we do this with elementary students. I go all the way up to high school, but this happens through college too. If any of you are interested in kind of seeing it or being a part of it, I would love to have volunteers if you're down here end of March or end of April. But you can also watch a movie based off of it too, which is kind of cool. If you've ever heard of the movie Spare Parts, George Lopez is in it, but it features a school out in California competing against MIT. So MIT is, of course, a school that competes in the international version for the colleges, but a small town community college takes them on. And so the movie talks about the struggles of this team, but of course there's some overcoming things that happen in it. It's a great movie. If you want to see, obviously they added some drama to it, but a little bit about how the ROV competition itself works, and it's really cool. This year, the winning team from my regional at the upper level, there's 3 different levels for the competition, so a beginner to advanced will go on to international, which this year is being held in Kingsport, Tennessee. So a lot of times they're based in the U.S., which is where most of our regionals happen, but I got to go to one year in Canada, so it was great fun to get to go to Newfoundland and check out how ROVs are being used in the more Arctic areas, which is really cool. I don't prefer the cold, but it was nice to visit and see and then come back down here. All right. Anybody have any other questions? Robert.
They did make the bottom of the Marianas Trench.
They did. You looked it up, so they have one that goes down there.
2014.
2014. Okay.
But they also found with that same ROV, they found it's crushed down too.
Yeah, it gets very difficult to get that deep. So most of the big ones operate max about 6,500 meters versus the 11,000 the Marianas Trench. Now there are the human occupied vehicles like the Alvin. He again also only goes to about 6,500 meters, and the Alvin is one of the most famous submersibles, right, that holds people. He holds 3. There have been a couple others that are made to go down into the Marianas Trench. One of them I know is still in operation. I do have, I think I stuck it up here. They are manned, yes, so people go in them. I do have a picture of the Alvin for you. So there is the Alvin. And then this one is very different looking, right? And again, this one is not an ROV, right? We call these the submersible or human occupied vehicles. This one was made to go to Challenger Deep, which is the deepest place in the Marianas Trench, and it was manned by, and mostly the designing of it was contributed to by James Cameron. So if any of you like the Avatar movies or the older Terminator or the Titanic movie, right, that movie director, he does a lot of underwater research, and so he built himself a vehicle to go down and do it. There's a cool documentary on it too. Nat Geo did that several years ago that you can watch, which is pretty cool. I think there's another one that more recently, Victor Vescovo is a former Navy guy. He started in 2019, had to pause in 2020, but wrapped it up in 2021. He made a new challenge for any of those crazy explorer people where you go to the deepest places in every ocean. And so he had a new vehicle designed to go into the Marianas Trench and repeat dive. The one that James Cameron built, I think it only made it down to the bottom for his mission, and then it had enough repair work that I don't think it was repaired. I'm pretty sure it was donated to the Smithsonian, but it wasn't made to continuously last and be out there, where this new level of submersible was made to continuously dive down to the deep part of the ocean. And I think Discovery Channel owns the rights to it, and I don't pay for the Discovery Channel subscription, so I don't know how. There's also the 7 Deeps Challenge is what they call it. So, all right. Well, let's move over to the fun part if anybody's interested. I will leave all of this equipment up here that you can come and check out if you want to. This one, I have the control box open. It's a little more advanced, but I have each of the remotes, if you will, up here that you guys can check out with the ROVs. And then we have a small one that is used for one of my competitions, and you'll see it's even smaller than this that we're going to drive in that tank back there. So anything I need to say before we cut off here, Mendel?
I'm going to actually bring this over just to
cool. Excellent.
Perfect. We will spread out the poster back here too. So if anybody is interested in seeing it, I'm going to plug it into a surface and send this to the water.
So Ricky.
Oh yeah, I'll break it. I'll find a way. What do you guys think? Do you want to
Oh, excuse me.
a little bit of tether. And this one is made to go to the pool. This is from one of the competitions. It maneuvers. It doesn't have big motors, but when it's in a pool, it definitely can scoot a little bit. So it should be ready to go. Go up and down,
Hey, Ryan,
forward and back.
can I hand you this? Would you put that on the box
I'm gonna
over there? Thank you. Yeah, thanks.
I'm gonna adjust the float just a little bit. And if you want to give it a go, now that I've handed it to you, so you have the switches, they just go forward and backwards, and then the top button is a little different than the other ones. Control the up and down. Try each one, you can kind of see how it moves. Yeah, and you guys can get closer. I can kind of stand out of the way or hide around the corner here. I did put some rings in there, so if anybody, I left the piece off. Well, you can push the rings around. I've got a piece I can grab, and we can give it a little arm if anybody wants to try to collect a ring, right? You always have to build an ROV with a purpose. I do, I recognize the big. I can't remember the name. Yes, okay. We talked about. You should try it.